Hello and welcome to a new episode of Scientific Stories. Today, our episode will take on a different flavor from the sea of knowledge. Instead of a scientist, I'm really excited to have on board Guru Kashwar Sridharan. He's currently undertaking his studies in marine engineering at AMET University in India. And in the last 2 years, he has been involved very heavily in marine conservation work around India, especially when it comes to ecosystem restoration work. So he's been engaged in different coral reef restoration projects, seagrass restoration projects, mangrove restoration projects, in addition to engaging local communities. So it's a very holistic approach, which is really, really inspiring to see, especially coming directly from someone so young. In addition, what I really love about his work is that he has a very strong element that combines both the engineering and the ecological aspect when it comes to conservation. So without further ado, I'm going to pass on the platform or the floor, and we will learn more about his work when it comes to something specific called Biorock reef restoration. It's methodology used for restoring coral reefs. So first off, welcome and thank you so much for joining us. I'm really excited for everything that you're going to say, and I'm looking forward to learning from you, and I'm sure everyone watching us has a lot, probably questions that they can get in touch with you later. But for now, I'll leave the floor up to you, so please enlighten us.
Thank you so much, Dr. Reem. Yeah, this is Guru Keshav from India. I'm a marine conservationist. I'm doing my marine conservation work just to save the ocean, because I feel like ocean is the real form of God, and I want to serve for God, so I work for ocean. That's what my motto is for. This is not my profession. I'm a marine engineer, so I want to do a small seva for the God, so I'm doing it for the ocean. That's what I see in my conservation works. So today, basically, we're going to talk about the important technology that's called Biorock technology, or mineral aggregation technology. This is quite famous in Indonesian reefs and Thailand and some other places they are using it, but it's completely new to India. By 2020 January, we have implemented it in India, and it's going successfully. I'm going to share a few things about how to construct a Biorock reef and advantages about it and benefits, and maybe some disadvantages of Biorock technology. And can we go to the slides? I'm going to say about Biorock technology. This is a completely a different method. This is not a natural way of growing coral reefs. This is an electrolysis method where we use electricity to stimulate corals growth, which will make corals to grow like 2 to 6 times faster. Specifically in hot corals, they grow like very fast, and soft corals act also very fast. So we're going to see about, this is invented by two scientists called Ulf Gulford and Thomas J. Gurio. And Dr. Tom is my guide. He helped me in doing Biorock technology in India and also in Andamans. And this is a quite interesting synchronized method where Wolf Gulford is an engineer and Thomas Gore is a biologist. They both combined used science and technology to save corals. This is a magical technology which helps corals to grow faster. I feel this is different kinds of like future science technology. This is the basic structure of Biorock method. What at the right you see a dome over there. That's a cathode structure. It's a metallic structure where we electrocute the structure from shore or using solar panel with the boya. We have an anode which gives the negative and positive for the cathode, which is the structure. We attach corals to the cathode structure, and there is an electrolysis process taking over there that stimulates corals to grow very fast. This is a picture we took in Gujarat where Dr. Thomas J. Gurio, he came to India by January 2020. We did the first Biorock technology project. It is a tunnel-shaped structure. It's 5 meters long. Government of India and Forest Department, Zoological Survey of India have collaborated with Global Coral Reef Alliance and made this project successfully. And what you're seeing, the white pipe over there is anode. We attached an anode with the structure so it doesn't move in the waves or any other external force. This is the boya we used for powering the structure. It contains two solar panels as per the requirement of power for the structure. We have installed it successfully. Okay, this is the structure. We can use any metal structure which is electrically conductive. We have used a specific rebars because it's round in shape, easy to weld, easy to transport, and all other things. So we used a round rebars over there. You can use this. You can weld as per any shape you want. We can ask for the geographical location of the area. We have to do some surveys and we have to design the structure as per that. So we can reduce the wave and also we can grow corals effectively. This is the electrolysis process which is taking place underwater when we electrocute the structure. The cathode, there is in anode there is oxidation and in cathode there is reduction where hydrogen at the anode from the oxygen. Where at the cathode you can see the limestone secrete over there. This is because of electrolysis process. When we electrocute the structure, there is oxidation takes place in the anode, and in cathode, limestone comes and settle automatically due to the electrolysis process. So this helps corals to grow faster. We know that coral reef secretes calcium carbonate to settle in some place. So we are giving calcium carbonate as an artificial method by this electrolysis process. So corals can concentrate on growing. So they grow very fast. This is how we collect the corals and tie it with a structure. We collect recently broken corals or which is seriously damaged by waves or any other boat anchor or anything. We collect the corals, we attach it with a structure with using of metal wires or nylon tags. We have to make sure that corals are attached very tightly so corals grow very fast because they get enough amount of electricity. Uh, this is just 2 years old coral structure. You can see that how spread it has been gone and the branching has been very good. Then we go to the advantages. The main thing is when you're going to pick the structure, it forms an artificial reef over there. Corals are there, so fishes are going to come over there. So if you're forming an ecosystem, not just as normal reef fishes, they're going to be a big ecosystem of fishes over there. And and the main important thing is we can use this technology for shore protection. While building Biorock technology near the shore, we can break down the waves easily. So, like areas like which has the high soil erosion, we can place it near the shore. So this process can reduce the wave erosions and we can save the land. So this is a survey and project we did. My guide Dr. Thomas J. Gorio have done this. You can see the difference in the two pictures. The left side picture, you can see a small curve over there. That's because of the wave. There's a severe erosion going on. The right side picture, you can see small dots near the shore. That's nothing but the Biorock structures. They have placed Biorock structures near the store. You can see within 3 years they have grown back beach. So this is an incredible technology to we can to grow back the beach. So till now, 8 beach has been restored by this method. So if we have any uh, secret erosions or any other things, we can use this technology so we can recover the beach as soon as possible. So this is in India. What government does is they lay so much of rocks near the store to reduce the erosion. But what happened? This causes drift erosion, which causes the next area. You can see the next part of the beach. You can see severe erosion over there. This is 2 times faster than the normal erosion. This is because of the drift erosion. So, but Biorock technology, which is underwater reef, so this effect doesn't happen. That's what. And Biorock method is used for coral reef restoration. This is one of the best method we can use for coral reef restoration. Not just branching corals, we can use soft corals, hot corals, stable corals. Mostly acropora has been used because acropora usually grow 20 centimeter per year. But by this method, we can grow like 2 times faster. Till now, there has been record of 32 centimeter per year and more and more. So protection against global warming. This is the best idea we can use for protection against global warming because corals get resilient to global warming by when they are attached to the structure, and bleaching is being reduced when if they are placed in the structure. This is a 4-year-old reef in Bali. This is an incredible project made by Dr. Tom. You can see all the corals at the bottom and soft corals at the top. It's a massive structure. Within 4 years, they have made this reef, and corals are growing very fast. And you can see the soft corals at the top, they are growing mad. And there are so many other marine organisms like mussels and oysters also attached to the structure. They got attached naturally. We didn't attach them. They got attached naturally. This is how this project works. Corals, corals and oysters, mussels and all things, they have been attracted by the electrical field and they come to the structure and they live over there. This is another 2-year-old structure in Bali. The main advantage is we can make this structure as per our wish. It can be at any shape, so we can mold the metal as per our wish, and we can place the corals over there. And this is in Bali. You can see it's a lotus-like structure, so it increases tourism over there. It's also a benefit. We Dr. Thomas used this method and saved like 99%. This is a place in Bali where there is 1% of living corals, and they have used the Biorock method, and now there is 99% of living corals. Okay, what you're seeing is the calcium carbonate which is produced by the electrolysis process. When you're applying electricity, there's going to be a rapid increase of calcium carbonate around the structure. This is 2 years old structure. You can see how thick this is, and this helps corals grow faster and corals spread all around the structure. You can see at the left corner, oysters attached to the structure. It attached itself and they grow faster. The main advantage of this method is if you keep on covering the structure, it heals itself. There is a damage by boat anchor. What happened after here? It heals itself. So reef heals itself. So electricity focuses on the newly damaged and it heals itself, and corals doesn't affect by this any damage. And there is rapid restoration uh, due to Biorock structure. You can see the difference in 1 month over there. Beach is covering the beach again. And we can use this method for seagrass restoration also. The same method, we doesn't need to attach the seagrass with the corals. We have to place mesh-like structure and make the seagrass grow in between them. So corals grow very fast and seagrass also. And we can use the same method to restore salt marshes and oyster reefs. As I said before, oysters grow very fast. So we can place the structure and place few oysters over there. And in few months, we can see there are many oysters will be there. Due to electrolysis process and electrical field, they got attracted and they'll be attaching itself. Now India is facing 45% of shore in India is facing problem called sea erosion. So I feel that Biorock technology can save shore and lands. So I'm doing this in India. You can see the left side picture where they have laid so many bags over there to protect the beach, but it doesn't work. So they have made a Biorock structure, and in just 2 to 3 years, 15 meters of beach has been newly grown. That is incredible. This is the Biorock which I was talking about. They have placed the Biorock. You can see a dark line near the shore. That is nothing but the Biorock structure they have placed near the shore to protect the beach. So this made to grow 15 meters of beach. This is in Maldives. So by saving the coastal areas, we can increase the country's economic and also natural resources. That is the main point. Biorock will increase economical growth also by increasing fishery growth, protecting lands, and tourism, and so and so. And these are small collaborations I did with Global Coral Reef Alliance. Uh, these are the 7 things I believe that we can save in Tamil Nadu where I'm living. Fishery restoration and coral reef restoration, protection against global warming, and shore protection. We can do with biotechnology and beach restoration and sustainable aquaculture. And we can save beaches from sea level rise, and we are saving corals. That's very important. It's 535 million whole species, and it's environmentally sustainable thing. This is the second Biorock structure which has been I have designed for forest department. This is a tomb-like structure. Now this is the biggest structure in India. It's 6 meters wide. This is the team I have worked with. Dr. Tom came with us to Gujarat in India, and we did this project successfully. And corals growing very fast over there now. This is me. I'm tying a massive species of coral. So main advantage I have said about this, not just the branching species, we can use massive species also. What we can do is we can choose massive species and we can make it as pieces of small pieces and attach it to the structure, or we can even attach the whole structure to the Biorock, whole coral structure to the Biorock. So we made it into pieces because it will help to grow very fast. You can call this method also microfragmentation. This is a small project. I did it in Tamil Nadu, India. We collected all the waste wooden pieces and made it as a reef like structure, and we placed it underwater at depth 3 meters. Within 6 months, we have activated a marine ecosystem over there. There are lots of fishes over there. So small kind of activities we can do. It doesn't need to be a scientist or a engineer or anything. We can do small sustainable things by like this. So we can increase the economical growth, we can increase fisheries and so on. So this is in another place in India called Andamans. There is an active Biorock working over there. There are 9 structures over there, and everything is going fine. There are different kinds of corals we have attached to the structure, and every corals has their own growth rate. So Acropora, they grow very faster than other small species, and there are lots of fishes over there now, lots of marine diversity over there now. We made a small presentation for Indo-African Summit about Biorock technology. The main advantage of this method is anyone can do this method. We just need a proper training. In Indonesia, kids like 15 age and 16 years old, they'll be doing this project because it's like a field, like agriculture. Like they have their own field and do the agriculture. So they have their own structure and get their own fishes from this structure. So anyone can do this project and get benefited. But in India, it's close to reef, so we need permission from government to touch the corals. So it's difficult in India to do. And thank you. Uh, Thank you so much.
Okay, so thank you for sharing with us like your experience and success story. And honestly, what I found very special about using this method is that it's not only for one thing. It's not
Yeah,
just for coral reef restoration. I love the different examples that you've shown and the success that this has proved in terms of beach restoration, oyster beds,
yeah,
seagrass beds. So it's like multiple ecosystems, really, not just one,
yeah,
which is
absolutely.
absolutely amazing. And I just loved the aspect that you put in because it's something I think is very lacking in the world in terms of finding initiatives that can be done by young people as young as teenagers. And I think that is absolutely amazing to see that this is something that teenagers around the world and young people are doing and implementing after doing a bit of training or being given some training. I had one question that's been like burning since I've been watching your
Okay.
presentation. It's about the reef in Bali that you presented in terms of having approximately 1% of live coral cover.
Yeah.
But after you
Yeah.
method, it went up to 99%. Do you know
Absolutely.
how long did that take?
It's 10 years.
It took 10 years to go there.
10 years. Yeah.
That's amazing. And
Yeah.
the other thing that I really loved, and also I think is something very important for communities like mine here in the Arabian Gulf, temperatures being constantly on the rise as a consequence of climate change. You know, our reefs are witnessing changes that have never been seen before. And for example, this year we've already had reports of bleaching in the Gulf. And for the past 4 or 5 years, a lot of bleaching events or episodes have been resident or in basically on our reefs. So we have lost a lot of our coral cover in that aspect. But what I have noticed on our field here when I go diving is that there are a lot of massive corals and very little branching corals. And usually in most of the coral reef restoration projects, everybody uses branching corals to restore reefs. So it's really refreshing to see someone using massive corals, because that is something that I was wondering about, the success rate and how that would work using Biorock methodology. Do you have you seen success using these massive colonies or corals?
Yeah. January, we have placed this structure in Gujarat, India. What happened is after 3 months, there is a natural bleaching occurs every year. But the massive species which is in the Biorock structure, the bleaching is very, very less. But the corals which are at the field, at the open, they have been bleaching. There is bleaching occurring. So there is a success rate. So bleaching is very less, which is electrocuted and which is not attached to the structure. There is a bleaching over there. Yeah.
Brilliant. Thank you so much. And honestly, you are an example for all of us to take initiative on both an individual and community level rather than just rely on the governments. So thank you for inspiring me and inspiring a lot of people around the world with the work that you do. Thank you for your time and for sharing your experience and success story. And this brings us to the end of our episode today. So for any of you listening or watching this video, if you have any questions about this topic or want to learn more about the work Guru does, please get in touch with him via his social media platform, which I will put in terms of both his email and his Instagram account at the end of this video. So thank you very much.
Thank you so much.